So in 6.1, we're going to talk about composite functions. And part of composite functions, what you need to know how to do is be able to simplify what we call these complex rational expressions. So when we simplify complex rational expressions, a complex rational expression is a rational expression whose, remember, a rational expression is a fraction. So it means you have a numerator or the denominator contains a rational expression. So notice here, this particular example of a rational expression, this numerator has a fraction in it. This denominator also has a fraction in it. So we have to go and take care of all that. So to do that, there are two methods to simplify these, and we're going to go through the first method, which require us to first, let's look at the first example and I'll explain what we need to do. And we'll write the steps after we do the example, or as we do the example. So it says 6x over x minus 5 divided by 12 over x plus 5. Now, to help you out, let's remember how to divide fractions in general. If I want to divide 1/2 by 3/4, remember, I'm going to leave this top fraction the same, and I'm going to take the other fraction at the bottom, flip it like this, and multiply it. So we're going to use that exact same process here. So what we're going to do is we see that we have a top fraction up here. So I'll write that as 6x over x minus 5. The bottom fraction is right here. So I'm going to flip it, x plus 5, and divide that by 12. Now, so my goal is to, once I get it here, I want to start simplifying. So what we're going to do now is, if we can simplify a number on the top and the bottom, we're going to do that before we start doing anything else. So notice here, in particular, on this 6 and this 12, they have something in common. They both have a 6. So if I divide the 6 by 6, I get a 1. Divide the 12 by 1, I get a 2. If I could, I would want to try to cancel out these terms here, but they don't cancel. So now I'm just going to multiply across. So look what I get. I'm going to leave the factors in terms of what they are. So I have a x times a x plus 5 over just a x minus 5. So here is this particular problem reduced. So let's look at the next example. And it looks a little more complicated, but it's really not. First step here, and this is going to be the first step we're going to write here to begin with, is before we can do anything with this, we need to go ahead and get a common denominator for the top and get a common denominator for the bottom. So first step is and what that means is we're going to simplify the numerator and the denominator first. So simplify numerator and denominator to a single fraction. And what I mean by that is you need to get a fraction on the top and a fraction on the bottom. 1. Right now you have multiple fractions on the top, multiple fractions on the bottom. So to do that, notice we need to look at the LCM for the bottom. So this one has a y squared, this one has a y, which means that this term right here is missing a y. The LCM is going to be y squared. So I'm going to multiply this term right here by y. So here's what I get. X minus 1 times y. 1 times y is just y over. And now they both have the y squared in common. So I've gotten it to one fraction on the top. Same thing on the bottom over here. Again, notice this has a x squared. This has an x. So this term right here is missing the x. So when I do that, I'll get y minus x over the common denominator is x squared for that LCM. And now notice what I've done by doing that. I've gotten a single fraction on the top, a single fraction on the bottom. The next step is to flip the denominator, flip the denominator to multiply. So here, I'll just leave the top the same. So x minus y over y squared times, flipping the denominator, I get x squared over y minus x. Now, if I can cancel something out, my third step is to simplify by removing factors. So if I have factors that are common, I can try to do that. Notice here I have the x is positive, the x is negative down here. The y is negative, y is positive. They're actually exact opposites of each other. Because they're exact opposites, what we can do, we can go ahead and cancel them out. And remember, when we do that process right there, we're just going to get a negative 1. So it just changes this to a negative x squared over y squared. That's your answer right there.